All right, so throughout this section, we've taken a look at fixed size or static arrays, which have a fixed number of elements. The array cannot shrink or grow in size. We simply specify the max size or the upper bound whenever we declare the array for the first time. And the array is always bound to be that size. It cannot grow or shrink. In this lesson, we're going to take a look at an alternate type of array we can use in VBA called a dynamic array. A dynamic array has a variable number of elements. So what we can do is resize it from time to time. Whenever it gets filled up, we can say something like make it a little bit bigger, or we can say make it a little bit smaller. And throughout the program's execution, throughout the actual procedure, it can grow or shrink in size as needed. So what I want to do here is repeat a very similar operation to what we did a few lessons ago. I want to store all the values in column A in an array, and then as I iterate over the array, I want to do some kind of logic to that and paste the results in column B. And let's keep it simple. Let's do something like taking the length of each word here and simply outputting it right here in column B. But the caveat here is imagine that we have a worksheet where the total number of values in column A cannot be predicted in advance. So let's say people are adding on or subtracting from this list daily. So right now this list is 5, but we want to write a macro that will be able to adjust to this list no matter how many elements are in it. It may be 3 tomorrow, it may be 10 the day after that. We want to be able to dynamically adjust to that, so we'll need an array that can be any size and fit whatever or however many elements are needed. So what I can do here is declare a procedure. I'm just going to call it array of values. And the syntax for declaring a dynamic array is going to be very similar. We're just going to do dim. We're going to bring our array name. I'm just going to call it column values. And I'm still going to provide the parentheses. The only difference here is I'm not going to put a number inside the parentheses. If you don't put a number, VBA will automatically create a dynamic array, and this can be kind of stretched to whatever size we need it to be. Now, this array is going to hold strings, so I'm going to do this. And the next thing I'm going to do is actually populate the array. Now, this is a little bit of an interesting scenario because this is a bit confusing when you hear it for the first time. So our array is flexible enough to be expanded or shrunk as needed, but we still need to tell VBA when we want to expand or shrink it. We kind of, we're buying ourselves flexibility here. We're buying ourselves the dynamic ability to adjust the array size, but we still need to clarify what the array's size will be at a given point in a program's execution. We can always adjust it later. That's what this buys us. The array is kind of flexible enough to stretch back and forth, but we still need to declare however many elements the array is going to hold at a specific point in the program's execution. So the way we do that is we need to figure out exactly how many elements the array will hold, which is always going to be dependent on how many actual elements are right here in column A. We don't want to manually write 5 because we can't always guarantee that there are going to be 5. So what I can do here is use our familiar final row syntax to get the total number of rows in the spreadsheet, and then use that as the basis for determining how many elements are going to be stored in my dynamic array. So what I can do here is declare a variable like final row. It's going to be a whole number, so a long. And I can use my familiar syntax right here, final row. We're going to use cells. We're going to get the total count of rows in the worksheet. We're going to do it in column 1, so this is going to bring me to the top, or rather the bottom left most cell in the spreadsheet. I then want to use my end key to go up to the last row of data, and once I'm at that range, I want to call the row property on that range to actually get the number. In this case, it's going to be 5. It could be any other number. So in order to actually expand our dynamic array to fix this, be able to expand to this size, I need to use a new keyword, and that keyword is redim. What this is short for is redimension, right? So you can think of a dimension as specifying the total number of elements that can fit in an array, and we are redimensioning it. We are granting VBA new knowledge of how wide this array can be, what its dimensions are, what its space is. So we are redimensioning our column values array, so we can write that immediately right here. And then what we want to put in here is the new final index position. So the exact same syntax that we're familiar with from the last couple lessons. So this is going to be the upper bound, the final index position. So in this case, what I want to do is use final row, But remember that final row starts counting the rows from 1 while the index position starts counting from 0. So we actually don't need to go up to final row. We can go up to final row minus 1 because essentially the value that's going to be in row 1 is going to be stored in index position 0, and that logic is going to proceed all the way downwards. So the final row's value is actually going to be stored in the final index position of the array, which is going to be 1 less than the actual final row itself. So the last index position that we're declaring here is going to be 4 for our column values array, while the final row itself is 5. All right, so now we have our array redeclared, and we can, of course, expand this. If we ever need to expand this, we can just write redim later on and either shrink it or grow it. It doesn't necessarily have to be a larger number. We can put a smaller index in here. An important thing to know here is that whenever you redimension something with the redim keyword, it's automatically going to delete all the existing values from our array. And this can be problematic. In this case, our array has nothing in it in the beginning, so it's not a problem to redimension it. But if you want to reuse this array later and you use redim, it's going to clear everything that is in the array. If you want to avoid that, you have to apply a special syntax here, which is after redim, you have to write the word preserve. And that's going to preserve the values if there are any in the array. In this case, we don't have any, so we don't necessarily need this keyword, but I wanted to point it out to you just so you're aware of it. So we're redimensioning the column values array. It's now going to have a total of 5 items at a max index position of 4. This is going to dynamically change depending on the final row and what value that provides us. So now I can go ahead and use our familiar syntax from the previous lesson, where I can declare actually an iterator variable, let's call it I, and I'm going to iterate for I, and this is a much better example of how L-bound and U-bound can be really helpful, because now if you think about the max index position of my array, I can't know what that is in advance. If tomorrow this column A has 100 values, I can't say loop from I equals 0 to 99 because I don't know for a fact that it's going to end at 99. But L-bound and U-bound, lower bound and upper bound, will dynamically calculate that no matter what size this dynamic array is, which makes it perfect for iteration. So again, L-bound and U-bound both take the array as an argument, so I'm going to pass it to here, to U-bound, also pass the array here. Let's go next I right here to go all the way till the end. And what I want to do is populate my column values array at index position I. And of course, what I want to do here is use cells. But remember, I can't just put I here because I is going to start at 0. The lower bound of the array should generally be assumed to be 0. So if I'm going to be starting at row number 1 for word, I want to make sure it's I plus 1 to start at row 1. Column 1, let's take the value from that cell, and I'm going to populate the array for the first time. The next thing I want to do is actually iterate over the array again, which is going to be pretty familiar syntax. And of course, these are all simple examples. You might be thinking, why not just iterate over the cells and just modify the value and paste it into column B? You certainly can do that, but for more complex operations, it can be helpful to store things in an array and then go through the array again and perform all the modifications there. Or you might need to store the data in order to write it to multiple places. And rather than kind of keeping all those things in mind, like range, you can just store it as an array as a kind of a general purpose container. But we're going to iterate over this array again from the lowest index to the highest index, and this time I want to write to cells I plus 1 column 2, and let's say what I want to do here, as I mentioned, is just take the length of each word, the total number of characters. There is the len function, which is the same as it is in the Excel interface. It's just len. It takes an actual value, and of course what we want to give it is whatever is currently being stored in my actual array at that index position. So we're going to iterate through all these 5 words, starting with index position 0, which is Word, then index position 1, which is Excel. Take the length of that. That's going to give us a number, which we're going to write to the column B, 1 column to the right. So this should work. So when I execute with F5, you can see we're going to get the output right here. Word has 4, Excel has 5, so everything is looking exactly as it should. And that's all there is to cover in this lesson. We talked about the concept of a dynamic array, which can expand or shrink multiple times throughout a procedure. We only showed one example here, but then you can reuse column values elsewhere. You can put it, for example, right here and redim it again to give it a different size. You just use the redim keyword, which is short for redimension. You write the array name or the variable name, and then you give it the new final index position. And the other syntax as well, where you use the to keyword in between the lower bound and the upper bound, should work as well here. Remember that the redimensioning of an array will destroy all existing values within it. If you want to avoid that, all you have to do is put the preserve keyword after redim, and that will keep those values. So you can, for example, populate an array with values from one column and then add on at the end of of those existing values with more values from another column. That's really all there is to cover in this lesson. I hope you enjoyed this section on arrays, and I will see you in the next lesson.